everyone, my name is Vivian Xiu Jiayan and my partner is Peng Shi En. Today we are going to present the question in physics module regarding PSPM 2008/2009. The first question we are going to talk about is calculate the centripetal acceleration of an object at the equator due to rotation of Earth. The radius of Earth is 6.4 times 10 to the power of 6 meter. Firstly, we should list out all the information given in the question, which radius is equals to 6.4 times 10 to the power of 6 meter. And then we are going to find the centripetal acceleration. We can find the centripetal acceleration by using A equals to R omega squared. And then sub the value of radius into the equation, but the information we are lacking of is the value of omega. So we can find the value of omega by using the equation T equals to 2 pi over omega. From the question, we know that the object is moving in the period of rotation of Earth. The Earth rotates one day, which one day have 24 hours. Each hour have 60 minutes. Each minute has 60 seconds. And then 2 pi divided by omega, where we can get the value of omega by using 2 pi divided by 1 times 24 times 60 times 60. Finally, we can get the value of omega is 7.272 times 10 to the power of negative 5 radian per second. So now, we can sub the value of omega into the equation of centripetal acceleration. 7.272 times 10 to the power of negative 5. And then finally, we can get the answer is centripetal acceleration equals to 0.0338 ms to the power of negative 2. This will be the final answer for centripetal acceleration. And now for 1B1 and 1B2, I would like to invite my partner Peng Shi En to present.
Hello everyone. So now I will presents the step of solutions for 1B1 and 1B2. Okay, so let's see the question first. So figure 1 shows that a 0.3 kg object is attached to a horizontal rod by 2 strings and each of the length is equal to 0.5 meter. The object is whirled with speed 8.0 ms to the power of negative 1 around the rod axis. And the question wants us to calculate the tension in the string when the object is at the lowest point or highest point. So from the question, we know that the mass of the object is equal to 0.3 kg and the length of the string is equal to 0.5 meter and the speed is equal to 8.0 ms to the power of negative 1 and the length between the both ends of the string is equal to 0.6 meter. So at first, we need to calculate the radius for the rotation first. So we can calculate the radius for the rotations by using the hypotenuse methods. And now I will draw a triangle to let my explanations to become more clear. So this is a triangle which presents in this figure. Here is 0.5, which is the length for the strings, and here is the 0.3 meter. Why I write 0.3 meter? Because here is 0.6. After we divide by 2, we will get 0.3. Here is 0.6. And now we need to calculate the radius, which is here. So radius is equal to square root 0.5 square minus 0.3 square, and we will get 0.4 meter. After this, we need to calculate the theta for here. So we can use trigonometric method, which is sine theta is equal to 0.3 over 0.5 and our theta is equal to sine inverse 0.3 divided by 0.5 and we'll get the answer, which is 36.87 degree. So after this, I would like to draw a free body diagram to make my explanations to become more clear. So when the object is at the lowest point, we will get a free body diagram like this. This is the object, and there will be a weight of the object which is acting downwards. So this is the weight, and there will be two tensions which acting upwards. And now we have found the degree which is here. And here will be have Ty, and here we'll have Tx, and here we will also have another Ty, and here we will also have another Tx. So now I will use the formula which is sufficient Fy equals to mass times centripetal accelerations. So from the free body diagram, we can know that the sufficient Fy is equals to Ty plus Ty minus weight is equal to mv squared over r. So why I use mv squared over r? Because centripetal acceleration is equal to v squared over r. And from the diagram, we know that the length for the both strings is equal, so which means the tensions for the both strings will also become equal. And we will get the answer, which is T multiplied by 0.8 minus 0.39.81 equals to 0.3 x squared divided by 0.4. So 1.6 T is equal to 50.943, and we will get the tensions for the string when the object is at the lowest point is equal to 31.84 Newton. So now I will present the step of solutions for 1B2. So when the object is at the highest point, the object will have another free body diagram. So now I will draw a free body diagram to make my explanations to become more clear. When the object is at the highest point, the object will have the weight which acting downwards and the tensions which acting downwards too. Why the tension now is acting downwards? Because when the object is at the highest point, then our string will hold our object like this. So the tension will acting downwards. And the degree will become here. So we will use the same method, which is sufficient Fcy equals to mass times centripetal accelerations. So the sum of the force which acting in y-axis now is equals to weight plus tension equals to mass times v squared divided by r. So the weight is equals to mg plus t cos 36.87 plus t cos 36.87 equals to mv squared over r. And now we just only need to sub our value inside this equation, and we will get the answer for the tensions when the object is at the highest point. So 1.6t is equals to 0.3 x squared divided by 0.4 minus 0.3 multiply 9.81. T for the string when the object is at the highest point, which is 28.2 Newton. So this is the end for these questions. Thank you.